Hello. Is it on? Okay. It's almost like SpaceX. So, welcome to Logan Startup Hub and EC Connect, guys. Welcome. Thank you for joining us, and thank you for everybody online joining us tonight. Tonight we've got Illia going to be talking about understanding serverless platforms. If you haven't been involved with AWS or cloud, don't be afraid. Illia will explain a lot of things, and it'll show you what is possible with the cloud. What are the next steps after physical computing, I guess. Yeah. But before we start, I'll just explain to you quickly about what we do here at Logan Startup Hub and EC Connect. So EC Connect is a software company. We have a team of developers and system administrators. We do mainly systems for telecommunications and utility providers. These systems provide software for the whole back end of their businesses. That includes billing, client management, payments, and we have a very large suite of IP around all these business support systems. Logan Startup Hub was started in 2017. We decided to open up a bit of our space to give back to the community, to have our startups and solo businesses work alongside a successful business, to be able to do mentoring, and for startups to really be able to work alongside a business who has a lot of skills and knowledge. So yeah, come down and see us, watch our Facebook page, connect with us, and we'd love to see you here shortly. So I'll hand over to Illia. Thank you.
Okay, thanks, Brad. That's a great promise that I need to explain AWS from scratch, from the beginning. All right, so the topic I'd like to talk about is called understanding serverless platforms, and that's something that I've been quite passionate over the last couple of years, and I think that's where I built a lot of expertise in AWS world. So I will probably just introduce myself quickly. So I'm a senior software engineer and IT consultant, helping some various kind of small and large businesses and startups. And I'd like to thank the Logan Startup Hub for having me here today. And I think over the couple years, I've been kind of lucky to work with very small and large organizations, like such as TopCorp. I think that was the latest place, and we had a really great experience working with AWS on really huge projects with kind of multi-million projects with a lot of data coming through, and different cloud providers too. So my background wasn't just in engineering, it was also a little bit in business and commercial law, so that's why I'm trying to talk not just from the software development perspective, so maybe some non-technical people will find it interesting too. And I think let's start with the system deployment techniques, and pretty much what Brad, I think, mentioned, that I would like to take a quick kind of walk through the history, and we probably start with some sort of bare metal deployments. So that's pretty much where everything started. So traditionally, applications have been installed on just some bare metal, like servers that we're having them on the desks. And it was totally like a business responsibility to make sure that it's powered, that it's upgraded, that we don't have any kind of accidents happening in the office. And the problem with that approach was that it also required a lot of investments, like because if you were going to start your own business and you were expecting a high load on the system, then you had to buy a very expensive hardware. And also you had to probably keep an infrastructure engineer or maybe some other people helping with the infrastructure maintenance and upgrading. So the development of some virtualization techniques, I think in the late 90s, they actually helped to abstract that hardware. So by creating like tools like VMware, so they basically helped us to run some virtual servers on a single hardware machine. So it helped us to actually offshore the worries about the hardware to the data provider or to the cloud provider. And we could just abstract the operating system. So now we didn't really care where exactly our operating system runs, as soon as it runs on that virtual machine. And later on, some major data providers and cloud providers, they actually made a really huge improvement by allowing us to deliver those systems in minutes, while previously we had to spend weeks ordering some hardware and trying to connect everything together. So the introduction of some operating system virtualization containers, such as products like Docker. I think Docker was released in 2013. It was like the next significant step forward. And it indicated basically the next phase of the deployment techniques. So what Docker allowed us to do, that we didn't really need to worry about operating system anymore. Because the Docker allowed to create packages with applications and all dependencies, so we didn't really need to even care much about the operating system we're deploying, because everything was just packaged in one kind of solid piece of called container. So it also solved a bunch of different problems. Like I think many engineers know that problem when it runs on your local machine, then you deploy to a test environment, doesn't work for some reason. So basically containers helped us to make sure that the environment is the same, no matter where we're trying to deploy. So I think the serverless, it basically allows us to focus only on the code. So it delegates everything like infrastructure provision and operating systems, the upgrades of the, I don't know, language runtime to a third party, such as Google Cloud, AWS, or Microsoft Azure. And initially, I think it's all started from a thing called function as a service. And function is basically just a small like snippet of code that you can execute no matter where it's actually hosted. So you basically just send a bit of code saying that, okay, I need to do some sort of an operation. Let's say if you run a company that does some sort of image processing, so it can be just maybe a Lambda that does, I don't know, thumbnails or something like that. And then you just send it to Lambda, it does all the magic. You don't really worry much about where it's hosted because you completely offshore all this process to the third-party provider, or to the cloud provider. So the only thing left to worry about was the code, because we didn't really need to know much about where it's running. And I think with the time, the definition of serverless expanded more, and now we're not talking just about the code, we're also talking about the databases, about some different like event buses, queues, and even services like AWS Fargate that allow to run containers. So basically now you can run container in the serverless environment. But I think if we'll think about the reasons behind, because it all starts with the reason, right? I would like to probably take a step back and think and consider majority of questions that I'm getting from different startup founders and different companies as a technologist. And those questions can be like, why should we move to the cloud? What kind of programming language should we use? Like, is it like C#, Node.js, Python, whatever? What the hell is microservices architecture? Why should we even care about it? Like, why should we use it? Why should we utilize Docker containers or maybe something else? Like, what was the problem actually of running everything on one single box? Should we actually pay for those managed services? Like, is it even better just to, manage everything by ourselves, so we don't need to pay to someone else and basically fund other people's business? Or why should we go serverless? And I think from my perspective, the answer to all these questions is basically that people don't buy drills, they buy holes. And it doesn't really matter what kind of technology you use. Your technology shouldn't drive implementation. What should drive implementation is some sort of innovation that you're trying to deliver. And what kind of technology you're going to pick? It's just a tool to achieve whatever you want to achieve. So I think that there was a great article by Ben, I think, Kehoe, and he said that serverless is more like a state of mind. It allows you to focus more on business rather than technology and technology selection. And basically, the product value should drive implementation, and serverless allows you to do that. So on the screen, you can see the evolution of system deployment techniques, but from a slightly different perspective. So this chart is basically showing how the modern deployment techniques can help businesses to increase their focus on business logic by decreasing their concern and control over stack implementation. So it's got the price. If you focus more on business logic and give everything to the cloud provider to manage, it means that you have a little bit less control over the stack implementation itself. However, you need to make that choice, whether you want to have control over everything or you rely on a cloud provider and can focus more on the business logic. From what I've seen recently, I think the focus on business logic is way more important. So, but it's important also to understand that when you're losing the control over stack implementation, that you have some sort of trade-off. And you need to understand what are the use cases for serverless and what are the use cases where you shouldn't probably use serverless. So you need to understand the benefits and limitations. So I think quite obvious benefit of serverless that there are no servers. That's why it's called serverless. So it's not really true because and I think technology people kind of know that there are still some servers running somewhere and operating systems and runtimes and containers, but they all managed by cloud providers. So we don't really care about where they host everything. And there is no such thing for business anymore, like defining some maintenance windows where you need to install or patch your operating system. You need to install, I don't know, the service pack on your Windows box. And then you need to find some sort of maintenance window when your system can be done. So it's also important to note that serverless is not just compute services. It's also, as I said, a bunch of other tools, including like even firewalls and API gateways and databases. So basically, we're not just talking about the server where you have your compute power. And the benefit of serverless that there is no need to worry about scalability and load balancing because they, by nature, inherently scalable. I think I need to explain what it means. So I just put like an extremely simplified schema of load balancer and traditional applications that need that load balancing. So let's assume that we've got like 2 users or 2 clients, and they send in requests, request 1 and request 2 to our system. And let's say we're not talking about 1 request, we're taking maybe about 1 million requests from first group of clients and 1 million requests from the second group of clients. So how it worked traditionally, it was sent via the internet, it was passing some sort of firewall, and then we had a load balancer. And then that load balancer could just redirect half of traffic to server A and another half to server B. That's how we actually could achieve that scalability. So if there is some sort of sudden spike in the requests coming, then we needed to provide some additional servers. Like we needed to provide servers like CED and all this stuff. So it could be all auto-scale. We could use auto-scaling groups, so it could be done automatically, but it required someone smart to set it up, but also maintain. So in a serverless world, it works slightly different. So if we have request 1 coming from the internet, it just invokes 1 function. Or in AWS terms, it's called Lambda. So it just invokes 1 Lambda. Then if you have a simultaneous request coming at the same time, instead of actually triggering the same function, the cloud provider will create a separate function basically a replica of the same function. So if you have request 3 and 4, the cloud provider will just create as many functions as needed to satisfy your needs. So obviously, the cloud providers, they're still kind of using containers behind the scene, but we don't really need to worry about it. And that's why it doesn't really matter if you get in 1 request or if you get in 500 requests. The cloud provider will handle that by creating all these different functions. And I just put some sort of comparison between those major cloud providers, just more to understand what are the limits here. And you can see that most of them, they have at least 1,000 parallel executions, which means that if 1,000 requests are coming, instead of just waiting for the previous one to be completed, it will just execute 1,000 times using different lambdas. So this means that your application can process extremely high number of different queries without any issues, as well as handle just 1 query from 1 client. And we're talking about functions that run only for like 100 to 200 milliseconds. So the amount can be pretty much unlimited. And unlike traditional architecture, we're not going to be overwhelmed or surprised by a sudden increase of requests, because I think quite often what happens is that you create a startup, it runs on a small box, it looks good, then out of sudden it becomes popular because maybe there was some good media about it, many people go and sign up, and your infrastructure can handle it. And then your kind of startup goes down, and you can't even handle the number of requests coming. So serverless allows you to build those scalable applications from the beginning. So you just build something once, and then it will scale to dominate the world. Some other benefits, I think, what is kind of important for, especially like in startup world, that you pay only for what you use. So if you created a bunch of those functions and you're not getting any requests coming in, you don't pay anything. So you basically pay for a number of functions executed. And the good news that most of the providers, they give you at least 1 million or 2 million executions for free a month, which is kind of enough to create some sort of proof of concept or the prototype. So you need to be aware that there is a bunch of other services that you will need to use from the cloud providers, and that's how they make money. But I think still most prototypes or MVP solutions can be just built without any infrastructure investments. So ideally, you will start paying for the infrastructure only after your application will get some sort of usage. And I think if your application is getting some traffic, hopefully, if your business model was right, hopefully you will start generating some income, and you will be able to pay for that. So another kind of great thing about serverless is high availability and resilience. So the cloud providers, they operate globally, and they have different regions, different availability zones. So if one of the availability zones goes down, then it will just spin up the same Lambda in another availability zone, so you don't need to care very much about a single data center that you can have, let's say in Brisbane, and then something happens in Brisbane, and you can't access anything. So because I think we still can see a lot of problems in the cloud space. Sometimes the entire regions are not behaving well, but it's still, I think, much more secure than just using local data centers or something like that. It's for my opinion, because otherwise, like let's say if you use something in Brisbane, then you need to have failover plan. If something goes wrong with that data center, you probably need to redirect all traffic, let's say, to a Sydney data center, which means that you probably need to keep a parallel set of kind of infrastructure up and running all the time in case of failover, which is quite expensive, also quite difficult to configure, and just adding like extra work. So the latency, I think it's another great thing about serverless, because there is no one origin server. So basically, the Lambdas will be created closer to your client. If you have a client in the United States and Australia, it's likely that the Lambda for American client will be created somewhere in the United States, and the Lambda for Australian client will be created in Australia. And it's all done automatically, so you don't need to worry about it. A few other things that Lambdas, they kind of help, and I would say the serverless architecture encourages to adopt more like a new mindsets for your software development team, because the nature of serverless is forcing you to use microservices and even nano-services patterns. That means that all components, they should be extremely isolated because they should run, they don't really know about each other, so they should run completely independently. And it has a bunch of benefits, and I think most software developers are familiar with those benefits, but we still kind of tend to, cut some corners, and find some shortcuts, while serverless actually enforces that microservices architecture, and it helps you to fix some bugs in particular components without affecting other components. It makes the release cycle a bit shorter, and testing is much easier. And another kind of great thing about serverless that I think you can have different microservices or nanoservices even written in different languages. Like you can have one microservice written in Python, another one in C#, and they will work together fine because they don't have that kind of common or shared code base foundation. And the last thing, the serverless is awesome. I think in any area of our life and business, we're trying to find passionate people. We want to be surrounded by very talented, passionate people that want to learn something new and encourage and actually be passionate about some innovation. What I found by working on the serverless solutions, that it actually helped me to engage developers more, to create that feeling of commitment, because it was a big kind of learning path for them. And they were so kind of passionate about learning some new stuff, trying new things. There was like a little bit of magic component involved when you're trying to do something that's not very clear in the beginning. And that's why I think they were also very proud, that they work on something really cool, shiny technologies, add some maybe lines to their CVs. So that's why I'm saying that using serverless actually will help you to attract more talented people to your business and more kind of proactive engineers. Okay, so let's have a look at the limitations. Unfortunately, the nature of serverless, because it's fairly new, it's been created only, I think it started becoming popular only maybe 4 or 5 years ago. So that's why there is still a lot of limitations that many cloud providers are working to fix. So the first one, and I think if we've got any kind of developers, they know that there is a problem of cold starts. And that's the reason of serverless, because what's happening, your kind of code snippet, it's placed in the container, so it needs to actually quickly compile the code, build it, deploy, and then it processes the request. So that kind of code compilation and build process, it can take some time. And AWS, Google, Microsoft, they invest a lot of money to solve this problem now. But what happens that as soon as your code was built, your Lambda or your function, it stays warm, and all kind of subsequent requests, they will be hitting that kind of warm Lambda, so it doesn't need to build it again. However, in majority of cases, the first Lambda can take from like a few hundred milliseconds to be created up to even like 10 or 12 seconds. And I've found like some analysis by, I think, Michael Shilkov that he did in the end of the last year. And I'm saying in the end of the last year because the things are changing so quickly, so it might be not very relevant now. Where he did some analysis based on the programming languages, so you can actually see that Azure, which is a Microsoft product, has probably the worst situation with a kind of C# language, which is also created by Microsoft. And it might take up to like 10 seconds for that cold start. While some other runtimes and different environments, they have different like stats, but you can see that it takes a bit of time. And I think that's what you need to consider, because obviously it's a very noticeable difference, especially if you run a customer-facing application or something. So no one wants to click on something and wait for 10 seconds to get the result. So the good news, this problem was solved. This problem was actually solved by introducing a thing called, like AWS introduced something called provision concurrency. And Microsoft has done something similar. They called it pre-warmed instances. where you can actually say, okay, for 24/7 hours, I want to actually keep at least one instance of that Lambda warm all the time. So that's why when you're designing some architecture or something like that, you just need to probably put some sort of classification against what is critical, what is not critical for the business, and just build it smart. So keep it in mind. All these other kind of workarounds like provision concurrency, it involves some extra cost, so it's good to remember. I think another quite a obvious limitation of serverless that it's stateless, and stateless means that they don't really have any cache. Like they don't really know about the context of why they're executing. They don't know anything about the previous Lambda that were executed. They don't know anything about other Lambdas that executed at the same time. So, which means that every time when Lambda is created, it's pretty much doing all the things from scratch. Like it doesn't really know anything about the context. And most providers, they have a timeout for Lambda. It's between 9 and 15 minutes. So if you've got something that should run for longer than 15 minutes, then probably Lambda is not the best option for you. Because first of all, it will be quite expensive, but also if it's not enough to complete the task, you can't just run the next Lambda and continue from the point when it stopped. Like you can, but I mean, you can use some persistent storage for that, but probably if you even consider that option, it means that probably you shouldn't use Lambdas. And also there is kind of another limitation, I think, if you start using persistent storage, because your Lambdas, they live on different hardware comparing to your storage. So you might face some sort of bandwidth problems when you're trying to actually download some stuff from the storage that might live on a completely different machine. So it will be a little bit slower comparing to more like traditional deployment where everything is hosted on one machine and has some sort of, I don't know, solid state drive or something like that, which is gives much better like input-output performance. Not all programming languages are natively supported by Lambdas. So I think all cloud providers, they support Node.js and Python. And other cloud providers, they have slightly different options. Like Azure is supporting, I think, C# and Java, while AWS supports a lot of different things. Like Google supports Golang. So it's basically kind of a limitation, but I don't think it's a real limitation because I think you can find the language of choice quite easily. I think I've touched base a little bit on these bottlenecks. Logs and metrics, that's another kind of a big problem because you don't have a monolith. Like you don't have one single application that can produce some logs. You've got many different pieces and something can go wrong and you can actually struggle to understand the root cause of the problem. So that's why everything is outputted to like a bunch of monitoring services like CloudWatch in AWS, but the analysis of those logs can be quite difficult. And that's why you probably need to use third-party tools such as ELK Stack, which is Elasticsearch Log/Kibana, or Splunk. And I think another thing I just wanted to highlight, that's something that I experienced, it's more like a shared code. Let's think that you have maybe a bunch of different Lambdas, and they need to have some sort of shared code that they all share, because they don't really know about each other. So each Lambda will have its own kind of version of that shared code, which means that if you want to change something in that shared code, you need to deploy it to all Lambdas together. So it's not a big problem, and like there is a nice quote here that the evil is of too much coupling between the services by shared code are far worse than the problems caused by code duplication. So that's why you also need to find that kind of the right balance. But I think it's more a challenge for system architects and designers. And the last one, but not probably the least one, is a vendor lock-in. So as soon as you start using something like AWS Lambda, I don't know, AWS DynamoDB, AWS Cognito, you can't just lift and shift it to Microsoft. Even though they have equal services and tools, it's going to be quite difficult to migrate everything from one cloud provider to another cloud provider. So it's not like EC2 instances or like virtual machines that you can just create, I don't know, 1 year you can use AWS, another year you can use Google, and you can just migrate, chasing probably the best discounts they can offer with serverless. And that's the reason why the cloud providers, I think, pushing so hard, because they want to have that vendor lock-in. As soon as you build something in AWS, it's nearly impossible to migrate it to a different provider. Okay, so if you remember, I was talking about that I like serverless, but it's not for every single use case. Like we understand the limitations and benefits, and that's why I just wanted to talk about when we should use serverless and when we should probably avoid serverless. So the first one is quite controversial because it's more about the APIs, and you can think about some sort of problems related to the cold start because the APIs should return data very quickly. However, I think it's still pretty great for APIs because of latency and because of that inherent scalability, that you don't really worry about the surges in traffic. So for example, I had an experience. I was kind of creating the application for schools, and they, like all parents, they go to that application and in the morning hours, between, I don't know, maybe 7 and 9 a.m. to order some kind of school breakfast, lunches, etc. And they had a very high load on the system during the morning hours. And no one was using it in the afternoon, at night. So it was kind of quite a big problem because we had to pay for extremely expensive servers, and we were using them only for a couple hours a day. So it's not a very green solution either. But basically, the serverless helps to solve that problem. And also, as I said, the great thing about the API, especially for existing applications, that if you have some old methods, some old endpoints from maybe an old part of the system, then you can just integrate it all together with the new endpoints by presenting more like a single endpoint or the single interface to your clients, and no one really cares what you've got behind. So it's pretty good for all kind of automated and cron services. So if you need to run something in the background, if you need to run something every hour, every 5 hours, every day, and those tasks can be even quite significant. So if you need to back up your database or change some configuration, you can what you can do, even if you're using EC2 instances, you can actually increase or decrease the configuration of that instance, so make it a little bit flexible. And I think it's pretty good for syncing with some third-party providers, where you need to pull data from third-party. You can just set it up to run, I want to run that Lambda every 10 minutes. Multimedia processing is pretty good too, because it's a very common scenario. If you will just Google serverless use cases, you will see a lot of image processing and all that stuff. So it's really good for image streaming, for some image resizing, all these kind of different tools. And you can also bundle it with a bunch of other services offered by cloud providers, like face recognition. So what you can do, you can just write a simple Lambda, upload the photo, and connect it to the face recognition service, and it will probably detect your face. Or it can be, it can be done just with a few lines of code. Basically in 15 minutes, you can create your face recognition something. Or we discussed just before today, AWS even launched something to track the satellites, something like that. And yeah, you can just use Lambda, and you can get access to some, I don't know, rocket science technology in a few lines of code, which is pretty cool. The event-driven nature of Lambdas, because Lambdas don't just do something by themselves. You need to trigger Lambda, whether have some sort of schedule, whether have maybe an API request coming in. And that event-driven nature of serverless, it's really well suited for events, streams, and batch processing. If you can just create a Lambda that will react to will subscribe to some sort of events, and it will be triggered every time when something happens. So which is pretty cool for payments, like payment providers, for authentication providers. So basically, you don't need to keep something up and running for 24/7. As soon as you receive that payment, you can trigger that Lambda. That Lambda will do some magic and return something back. So, and you can also subscribe for the stream. So basically, you can just keep all events kind of streaming instead of just processing file by file. which is quite nice. Ingestion and data processing, it's something that I'm going to actually talk a little bit more in the future because that was something that I've been working on. Non-complex Internet of Things systems, AWS is big on Internet of Things. Like if you will go to the AWS services, you will see that they have a huge amount of Internet of Things services. Why I said that it's non-complex Internet of Things systems? Because if you really have a complex Internet of Things system with million requests coming every minute, then it will just become extremely expensive because you will need to create all these lambdas and all the time. But it's pretty good if you just need to do something kind of simple, I don't know, have some sort of light detection, I don't know, something like that. CI/CD pipelines. Not sure if everyone knows what a CI/CD is. More like continuous implementation, continuous deployment techniques. And that's or continuous integration, continuous deployment techniques that allow you to build some code and deploy it, run some tests and deploy it automatically to production. And Lambdas are pretty good for this because you can actually run Lambdas to do all these activities. Like the Lambda can maybe run some, I don't know, smoke tests, integration tests, something like that, and deploy it automatically. So you can create some webhooks to GitHub, et cetera, et cetera. OK, it's not really great for systems with very predictable and constantly high load. So mainly because it will become quite expensive. If you know that you need to process 100,000 requests every minute, 24/7, then there is no point of running Lambda. You can just find the right size of virtual machine or something like that, and it will be way more efficient. However, you still can utilize some other serverless services. Like you still can utilize maybe a serverless database. You still can utilize even maybe a container where you can, serverless like AWS Fargate or something like that, where you're going to keep your container. It's not great for complex and long processing tasks, mainly because of the timeout issue. So if you've got something that needs to run for more than 50 minutes, it's probably not the best way to use Lambdas. If you need to download gigabytes of data, probably you shouldn't really download it into your Lambda. It would be smarter to use something else. And it's also quite difficult to achieve the parallelism in Lambda. Like if you want to actually process a request like in maybe 5 different threads, Lambdas, they're mainly designed for one kind of thread at a time. Or I would say that the Lambda itself is kind of a thread. So if you want to achieve that parallelism, it's much better to just build your logic around creating multiple replicas of the same Lambda. So as I said, Lambdas, they also have some memory limitations. Like the Lambdas, they cannot have more than 3 gigs of RAM. So obviously, if you have something that requires a lot of kind of memory allocation, it's not great. Same as Lambdas, they don't have much of the persistent storage. Like you can download something. I think in AWS, I think it's 512 megabytes that you can keep within Lambda. But again, if we're talking about processing of terabytes of data, probably you need to build it slightly differently. And we also discussed some limitations around that cold start. And what I found that sometimes we have service level agreements as a product. And under service level agreements, we can't really allow even to have 2 seconds delay or 1 second delay. So just be careful about it. As I said, it can be solved by using provision concurrency or something like that, but it's just something that you need to be aware of. I just want to probably talk a little bit about something practical that we built. So that was a system that I built at TopCorp, and I've been kind of working with a team that was working on the business intelligence solution. And the business intelligence solution was around some data that we were consuming from more than 35 different data providers. So we need to get data from all different providers, load it to one data warehouse, and then do some data analytics and business intelligence. And when I started there, so I just kind of quickly realized, and I think many people who worked with data, they probably agree that the biggest problem is to get quality data. It's not about some machine learning, artificial intelligence tools. It's more about just getting really good quality source data, because different providers, they can send different, I would say, rubbish data. And sometimes if you don't validate the data in the beginning, you run to some problems later on when you're trying to load it to data warehouse and then process it. So in our case, majority of data just contains some daily figures. And we needed to build a single data integration solution for all providers. And the data was sent initially via a bunch of different tools. There were like some third-party APIs. There were some FTP servers, cloud storage, something like Dropbox or Rackspace. They were even using like website scrapers, because not all data providers have their own API, so you don't give access to that API easily. And that's why the task was basically to build something simple that can integrate all these data solutions. So if we need to, or data providers, so if you need to onboard a new data provider, we can just give the same solution that to others. And the requests were, the requirements were basically that we needed to have an option that we could request data. So we didn't allow to send everything we wanted. We wanted them to ask what data you need, and only after that send it. We wanted to verify the data sets before we process them. We also needed to keep encryption in transit and at rest. And obviously, we wanted to build a cost-effective solution to handle spikes, because we were talking a lot about daily data, and those files were coming early in the morning. And that's why we had to run 5 different servers with quite a lot of money spent on them. So we were talking about like thousands of dollars every month. And our assumptions were that we were getting like 35,000 files daily. The average size is like 3 megabytes, but some files can be 150 megabytes. And the load spikes were between 5 and 9 a.m. So I will try to not go very technical here. I'm not sure if it's going to work, but let's just have a very quick look at the solution proposed. That's pretty much, I just want to display, want to kind of showcase how different serverless services can be used together. So it's very kind of, and it was intentionally a simplified schema here, even probably too simplified, but it will become a bit more interesting. So first of all, we decided that, okay, we want to have a control of what data is sent to us. So how are we going to achieve this? We just created some tables in Amazon DynamoDB, and we just said that, okay, we created some schedules, and we say we need that file to be received every day. And we called that kind of requirement our job request. And we placed it in DynamoDB. And obviously, we created AWS Lambdas, more to run all kind of create, read, update operations in the database. And the CloudWatch, as I said, it's just kind of for monitoring the logs. And we said that in CloudWatch, we also set up a schedule, so that Lambda could place new schedules every day, every week, so basically based on our requirements, whether we need to receive data every week, every 15 minutes, every day. So we had that Lambda that was generating those job requests. Okay, now it's getting a bit more interesting. We started using the API gateway. That's a service from AWS that basically just creates the endpoints. So like www, something that you can send some requests. And we started using AWS Cognito, which is another like serverless authentication service. So, and the kind of a very simple idea was that the data supplier needs to log into our API, authenticate against Cognito, get some credentials back, get the requests that we're asking, and then send us files. So, because we were talking about large files, like 150 megabytes, you don't really want to send it over the API, like HTTP and all that stuff. So we started using S3 buckets. And S3 buckets is a storage service from AWS. And we were just given a temporary credentials so they could load files directly to S3 bucket. And S3 bucket supports like multi-parent upload, all the stuff, so it allows you to load terabytes of data. And we were given just like a temporary credentials, like you have 30 minutes to load what we asked, or 1 hour to load what we ask, so you can modify this. Okay, then as soon as files arrive to S3 bucket, it's sending the message to the queue. And that queue is used by AWS Lambda. So basically, Lambda subscribes to the queue. As soon as message arrives here, we run Lambda to validate the file. So we check in, did we expect that file? Yes. Does it have all necessary fields, all mandatory fields, all the kind of field types and all stuff? So we created a bunch of Lambdas basically to do that validation of each file that we're receiving. And then if it's all good, we were kind of converting those files from different formats, because sometimes they send us in CSV, sometimes they send us in XML, in JSON. So we were just converting to a single format, and we could load it directly to our staging database for future ETL and processing. So as you can see, a lot of moving parts. And I think when you build software, any kind of software product, you know that things never go this way. You always have some sort of issues. So in order to address those issues, we started using another service called AWS Simple Notification Service, or SNS. So basically, it's a notification service. So we just said, whenever something happens in Lambda, if we have that Lambda crashed for some reason, or if we have some sort of issues, or if our queue is not getting emptied, like we started using a thing called dead letter queue. So if our request cannot be processed for some reason by Lambda, then that request will not disappear. It will go to the dead letter queue. The dead letter queue will will send a message to SNS topic. That SNS topic will send emails to our support mailbox, but also because when I started creating Lambdas, I just couldn't stop creating Lambdas. So I just created Lambda that also sends Slack notification. Or you can build something on top of that. Like SNS by default supports also text messages. Like you can send some text messages. So it's pretty cool and powerful stuff. So the schema I'm demonstrating here is kind of simplified version. It's way kind of more complex. But the beauty of serverless world, that the entire process from the venue to get these credentials, upload stuff, do all this processing and output to the staging database, it only takes a few, 100 milliseconds, maybe 200 milliseconds. So it's very kind of small delays. And what we've done, we created all components as a separate, completely independent services. We had authentication service, job request service, error handling services, all other different services. And we just used some shared services in the middle, more like our middleware. So error handling service doesn't know anything about authentication service. Authentication service doesn't know anything about job request service. What they do, they may send some messages to the queue and say, OK, I received the file. I just send it to the queue. I don't really care what's going on with that file after. While maybe job request service, as soon as it can see that message come into the queue, it knows OK, I see that message, I need to do something now, etc. And we also kind of used a few other services like AWS KMS, it's for encryption, decryption. Route 53, it's more for the DNS resolution lookup. So a bunch of different things. So, and just to kind of briefly say what the outcomes we've got out of it. We just tried to do as much performance tests and throughput tests to understand what are the limits. Actually, we struggled because we couldn't load files kind of quick enough or fast enough to get them processed, because we were trying to load 1,000 small files in about 2 minutes, but we just had that kind of network constraint on our side because we couldn't load them faster. And if you think about 9,000 small files, it ended up having 9,000 function executions, 5,000 DynamoDB read writes, 4,000 messages sent to SQS, 9,000 calls to S3 bucket, and maximum 68 messages we had in the queue at the same time. So it's kind of huge numbers if you think about it. And then we had also a load test, let's load 91 gigabytes of data. But again, we kind of struggled with our internet, Australian internet. It's not probably the best thing about Australia at the moment. We tried to load 91 gigabytes of data. It just kind of took really 15 seconds to process, which was quite powerful. So our assumptions on the costs, because in the end of the day, you need to prove to the business that this solution works. And as I said, we previously had 5 different servers that we had to run, maintain, and the total kind of cost was, we were talking about like tens of thousands of dollars a year. So we were thinking that to process a single file, we need to do 38, we need to actually have 38 different events to establish a session, do all these validations, etc. And we were talking, okay, we need to process 40,000 files from like 100 customers. So we're talking about 4 million files to be processed or 12 terabytes of data. And our estimate was that the variable cost will be $38 per month, and the fixed cost will be $5 per month. Not US dollars, but it's extremely cheap. Managed to save us probably, I don't know, almost like 50 times, I'd say. So I think the reason for that kind of success story was that it was built right from the beginning. It was a greenfield project. We could do this kind of cost estimation, all this stuff, fairly easily and clearly. And yeah, it was kind of something that I can use to prove that serverless solutions work, even at the large scale when we're talking about terabytes of data. So what we learned, the good thing that, and what I like about cloud development in general, that you can use infrastructure as code. I personally don't like reading documentation because I barely see good documentation. It's very difficult to update. Like, it's normally just in one person's head. And I also don't like documentation about how to set up a new environment, something like that. When you come to a new business or something like that, and you need to set up your new environment, and you always run to these problems, that something in the documentation wasn't updated. Something that worked on Windows Server 2003 doesn't work on, I don't know, Windows Server 2019. And it actually becomes quite a nightmare to deploy exactly the same environment that we have in production, somewhere in test. Actually, back at TopCorp, we have like multi-million projects trying to deploy similar environments to the test, mainly because of that complexity. So, and when you deploy something to the cloud, you basically create this infrastructure as code. So I didn't allow anyone to go to the console and click on things like I need to create this service. You can just create the cloud infrastructure definition files, like YAML files, where you can define, okay, for the error handling service, we need to create 3 lambdas, maybe 1 DynamoDB table, all this stuff. And I found that it's probably the best documentation because it's never getting outdated, because you can't really update anything without updating the definition file. So strongly recommend for everyone. It allows also to create complex environments in minutes. Like if you have all these definition files, you just change the parameters that you pass in. And one of the parameters, like we used, could be just a stage or maybe environment identifier. And you just create that new environment in minutes. Like we did a penetration testing, and obviously the third party, who was performing penetration tests, they asked for a new environment. And I can imagine that it could take like hours really to build in the old ways. Like for myself, it took only like a few minutes, just pass new parameters and deploy it. Code reviews for infrastructure changes. Quite important thing because normally all the infrastructure is set up by one smart guy, and they just create it. And no one really understands how it works, but it works and everyone is happy. But then in 5 years or 10 years, if you want to replicate the same, you don't quite understand how it's working, like how it's working in production. The good thing, as soon as you have your infrastructure in definition files, whatever you make the changes, you do code reviews process and all these kind of things. There was a thing called security as code. It was, I think, introduced just fairly recently, but that's something that where you can actually involve your security teams to do some analysis of the infrastructure that you're deploying at very early stage. So instead of approaching your security team and saying, okay, we've built this application, can you please check if it's secure? you're basically saying that, okay, we're going to build this document application, and this is what infrastructure we're going to use. This is what kind of encryption we're going to use. Are you satisfied or not? So you involve your security teams earlier, saves probably millions and company reputation later on. DevOps engineers, not sure if everyone knows who are DevOps engineers, but DevOps engineers are basically all these people who help to create the right infrastructure for the applications to run on the data centers or cloud providers. So basically how it works is that you have a database engineer, maybe you have an application engineer, they create some sort of application, then you ask DevOps, can you put it on the cloud? They do some magic, no one really knows what's going on. Like DevOps engineers don't really know what they deploy into the cloud. Kind of software engineers, they don't quite understand how it's all getting deployed. And poor QA engineers, I think they don't have a clue of what's going on in general with all this stuff. And we go here and we can see that our infrastructure definition and CAN deployment in the serverless world can go side by side. Because if you create a new Lambda or if you create a new DynamoDB table or something like that, you can't just go and ask your DevOps engineer, can you create a new Lambda for me? Can you create a new table for me? So basically just go side by side. Like you write the code and you define that infrastructure. And that's why I think that kind of line between DevOps engineers and software engineers, it becomes very kind of blurry because it's very difficult to understand where one kind of set of responsibilities ends. So that's why it's very important for developers to understand the cloud services and their limitations. So it kind of helps you to build that very comprehensive knowledge. So it increases the importance of professional development. So that's why it will be likely that you will encourage people to go and obtain some certificates, etc. But also they become a little bit more passionate about their work if you write the right people. And it's not boring because you're not just writing code. You can go and create some infrastructure, which is pretty cool. And like back in my team, we even had our kind of QA engineer and even business analyst who completed the AWS certification because they just wanted to understand how it works. And I think it builds that really good commitment to the product and to the business too. QA, they're also part of the DevOps world. And that was actually a very big problem. We've got a few people who understand how the cloud kind of serverless infrastructure work. We've got a few people who can understand how to write the right code and utilize the power of serverless world. And we almost don't have any QA engineers who understand how to test all this stuff. Because it's quite challenging, a lot of things happening under the hood. Like you can't really manually test, how many messages arrive to some queues, et cetera, et cetera. However, I found that testing is extremely valuable in the serverless world. And because your Lambdas, they interact with very independent services, so you need to actually be able to test all these independent services. So QA engineer need to be familiar with the cloud provider so they can actually monitor the messages. They need to understand what's going on there. And it is kind of way more than just kind of testing user interface against what you expect to see. So that's why I think scripting skills and knowledge of command line tools is essential for QA engineers if you want to go to the serverless testing. They also need to understand probably how to automate all these tests because, as I said, a lot of things just hidden. And the role of QA engineers, it becomes like extremely huge. But as I said, like from my perspective, if you build in one team, it doesn't really matter what kind of role and what kind of title people have. Like QA engineers can give really good advices about the architecture. Business analysts can do really good advices, etc. And another kind of important lessons that we learned is automated CI/CD pipelines. So as I said, like continuous integration is more the practice where you just commit all code changes to one single code base. And then the automated pipeline can build that code and actually tell you that the code got some problems or something like that, run some unit tests. And continuous deployment basically deploys all the changes to production. So the serverless deployments can be quite difficult because you deploy to a very decentralized cloud services and resources. And that's why you have a bunch of different, that's why it's very important to automate, but be aware of some additional restrictions. Where you can have, like, if you want to, let's say, you can create a S3 bucket, but you cannot delete a S3 bucket without removing all objects first. So it just won't allow you to do that. So that's why it's very kind of important to make it all pipelines as code. Because if you have one smart person in your team who is aware of all these kind of small limitations, like we need to remove all objects first, it's kind of great, but it is manual. And one day, someone will forget about it, and nothing will work. So that's why it's very important to define pipelines configurations as code. And as soon as you have pipeline configurations as code, you can also do code reviews. Because I would say 99% of times I've seen any kind of CI/CD pipeline. It was created by someone, and no one else understands how it works fully. They just like, yeah, how do you deploy? We just click this button. Something like that. Doesn't really work well, especially after that person leaves. So I would say that ideally all these deployment scripts, they should be tested, and they just should be defined more like UML diagrams, where you can say that, if we need to, I don't know, upgrade this service, then if yes, then we do this, this, and this. If no, then we do that, that, and that. And it should be also tested. I don't really know many companies that test CI/CD pipelines. They normally just test the code. They test the application itself. No one really tests how it's getting deployed. But it's quite important, right? Because if you deploy something wrong, your application can be down for days. Like the way how we kind of quickly, I will explain how we build it. So we had our kind of GitHub repository where we had the application code. We also had all these deployment scripts, CloudFormation templates, and we also run a bunch of automated tests. In our case, because in the company we normally had more like C# and Microsoft stack engineers, so our kind of QA engineer just wrote the code in PowerShell, and that kind of just executes sends some test messages, and then checking that all kind of queues being populated, all that kind of stuff. So then we use like GoCD server, and we deploy to different environments like dev, UAT, PPR, prod. And in our GoCD agent, we basically just run built-in unit tests, so where we package all the code, then we deploy to AWS using CloudFormation templates, and that's more like those CloudFormation files that define what kind of resources you want to create. And then we also have, again, another like PowerShell script to do some smoke tests that everything was deployed fine. And then as soon as we deployed, the GoCD agent, by the way, runs on AWS Fargate. So it's another like serverless service. So when we need to deploy something, we ask, OK, Fargate, please create an agent so we can build all this stuff. As soon as it's deployed, we're saying, OK, now we can kill that agent. So we just pay for like a few minutes of that execution, which is kind of nothing. Yeah. OK. Let's kind of summarize maybe some points that we discussed here. OK, the serverless I consider is the next stage of system deployment techniques after virtual machines and containers. And I don't think it's only my opinion, because if you look at the amount of money invested in the serverless world by all major cloud providers, they're moving into that direction. And I think we will need to follow anyway. And we have talked about why we should consider serverless. And I was trying, I think, to deliver the message that it's not about technology in the end of the days. It's more about the right tool to do stuff for your business needs. So please focus on the business value. I think that serverless can actually help you to focus more on business logic rather than worrying about infrastructure, operating systems, runtimes, and all this stuff. So we know that we've got a bunch of advantages, such as scalability, cost effectiveness, high availability, It's very rare that those services will not be available. It's nearly impossible. And AWS and some other cloud providers, in their service level agreements, they guarantee the availability set to like 99 point, I think another like 7 nines for some services and 11 nines for other services %, which is very reliable. Still not 100%, but I think if you just host everything by yourself, your risk's a little bit higher. It's not suitable for all use cases because it's got a bunch of limitations. I also mentioned that infrastructure as code is completely critical. And it allows you to do code reviews and do a bunch of other things related to the cloud deployments. In terms of how it affects your team, probably your developers will be very happy by working on serverless stuff because it just kind of keeps their work a bit more interesting. And if you hire right people, they're normally keen to learn more. So if you're getting some resistance and people don't want to learn serverless and all that stuff, it's interesting. But I think the line between developers, DevOps, and QA roles is getting kind of blurred. Because I think if you work on the serverless, it doesn't really matter what is your role. Because the amount of code that you need to write is becoming kind of fairly small. It's all about those connections and all other things. And that's actually a key to build a true, kind of cross-team collaboration where you don't really worry about the title much. And I would also recommend to invest into automated CI/CD. Many businesses, they see that as a little bit non-essential investment. Like, we build something, we can deploy it manually. Like, why do we need actually to pay more? But I think if, as soon as you automate this process, you can actually deploy it and delete all these kind of microservices in seconds or minutes. And it might not look like great from the, for a single deployment. But as soon as you go to a very kind of, I would say, very quick release process, like of shorter release cycles, then it will just multiply the amount of time that you're saving. Like, we did our releases, I think, every 3 or 4 days, mainly because we could just release in 5 minutes. Like, it wasn't a problem at all. And I think we also discussed that because we're talking about a bunch of different independent services that are quite isolated, that serverless can be very fragile. So you can accidentally break one service, and your solution might not work. And that's why it's very important to keep all configuration files, deployment scripts as a code, but also do a proper review and testing. And serverless allows you to test everything. And you don't really need to write much documentation because all these scripts and all these kind of deployment configurations, they help you to, they're kind of self-explanatory. I think that's pretty much everything I just wanted to share today about the serverless stuff. I hope it's been useful. And yeah, feel free to ask any questions.
So just talking about everything becoming code, because I know how quickly it is to run up a VM, but you're now saying that with serverless, if infrastructure is a code, what's the overhead in terms of developing that? It seems like there's a bunch more code streams now that we've got with CI/CD and all the rest of it. So how long does it take to set up that as opposed to older technology which we know how to deploy in a moment?
I think it's a really good question. I think it depends. What I found that you still need to do a lot of manual steps even with traditional deployments. Like, if you're trying to deploy something to VM, or let's say if you're trying to deploy something to VM as a Docker container, then you still need to create the Docker file, you need to create maybe some sort of make files. Like, you still need to actually have some sort of configuration files created. If we're talking about like pre-Docker times, then it was even more terrible. Like, you had to do it manually. And when you do it manually, you never know, it's going to take 1 hour or it might take like a week. And that's why I think because you built your infrastructure together with the code, it actually makes it quite natural that as soon as you kind of progress with your code, you can add the infrastructure pieces. Like you write a Lambda code, and you create that Lambda as an infrastructure resource. So they go like side by side. And I think there is no thing like you need to build infrastructure first, and then you need to start writing the code. So it's just part of your normal iteration, where you're just saying that, okay, we need to create a new microservice. And obviously, as a part of that development, you develop the code, and also you build infrastructure in parallel. So I think it's actually quite exciting. I don't think it takes extra time, but it definitely keeps people a little bit more engaged because they can touch different components like infrastructure as well as code.
Okay, cool.
Yep.
Any other questions?
One of the projects I work on is around sensitive data and data sovereignty, and there's a geofence around that. You've got to keep it on Australian soil or New Zealand soil or Argentinian soil. Is that possible with serverless? Do they put a ring around stuff, or is that once it's out there, you don't know where it is?
Yeah, I think in terms of like sensitive data, because I've been working in the space where we had to deal with a lot of PII data too. So we actually had to pass all the kind of different audits and penetration tests and all this stuff. So and we actually have quite a big obligations from the regulator to keep data secure. AWS, I think, is the most mature at the moment, because like there were some problems with some other cloud providers. Like I don't know if you know, but a few years ago, Microsoft had a problem that even though they had all their servers in Australia, their backups were sent, I think, to Singapore or something like that, and it created, I think, quite a big problems for Microsoft users. AWS is very mature, like because the government is using AWS. Even the new COVID Safe app, I think, has been built on AWS infrastructure. Yeah, and basically, I don't think I've seen that kind of concerns around security now. You need to be obviously, you need to have some sort of expertise and knowledge about AWS regions, availability zones to make sure that you keep data in the right places. I think when you keep data, I think for different jurisdictions, like for different countries, then you need to make sure that you don't actually mix data within one region. So all data that belongs to, let's say, Australian customers, they should stay in Australia. Or in Argentina, you can use just one of the local regions over there. We're quite lucky that we have our own region in Australia. So we can actually keep all data hosted in Australia. While I think some countries, they're not that lucky. And then you need to look at the particular regulation in each country. But they also have a bunch of security measures around encryption, decryption, all these kind of keys. They're all kind of managed, automatically rotated. You can use it. You can use encryption. Like we had requirement to have everything encrypted in transit and at rest. And when we did audits, we never had any problems with that. Obviously, you need to be aware of some of the kind of underlying infrastructure in AWS, how all this data is transferred from one service to another. But as I said, the governments are using AWS around the world now. And that's why I think it's getting much easier now to convince the regulator that it is safe. Because even like 3 or 4 years ago, it's been quite a difficult task. Like we're moving to the cloud, but cloud is not secure. Let's keep it on premises.
Yeah, we still get that. Yeah, it's on the cloud, but it's still not secure.
Yeah.
How quickly can you run up a Hello World serverless platform?
Maybe like 5 minutes.
That'd be cool to see.
Yeah. Basically, it's interesting what you call like serverless platform. If you just want to spin up a Lambda and attach it to the API gateway so you have the endpoint, that endpoint reaches that Lambda, then yes, it's kind of fairly simple solution. And when you even go like from the console, and I don't recommend to use console, but you can actually go to the AWS console on the website, and you can actually even write the code just there. So you can just write something like return hello world, attach it to the API endpoint like manually, and it will return it. The only thing that it's not very useful, but they have a bunch of templates for different scenarios. Like if you will go there, they will tell you like, okay, if you want to write the API, that's the template you can use. If you want to, I don't know, read-write from database, that's the template that you can use. All these kind of things. Yeah.
Quick question here.
Sure.
So we have a large monolith application, as you could probably imagine.
Congratulations.
15 years of development.
Yeah.
But it is very convenient in a lot of ways. But just say if we were to split it up into many different microservices, would each microservice normally have its own like Git repository?
That's a tricky one. I personally don't like keeping different repositories. Like you will see that a lot of best practices will be around having each microservice in its own different repository. In our case, we didn't really go that way because I found that there is a bunch of things where you need to perform some end-to-end testing, like integration testing. It really depends also, I think, on how actually loosely coupled are your microservices. Do they use separate databases? Do they actually communicate to each other in any way? But what we found that for us it was much easier to keep microservices under the same repository, but make sure that they just completely isolated and independent.
So is that like then the CI/CD pipeline would deploy the relevant code?
Yep, that's right.
Microservice?
That's right. Yep. So basically, in the configuration file, what we've done, like we have, I think, 10 different microservices. We have our kind of release branch or whatever we created a release. And then when we deploy, we can actually specify what kind of microservices we want to deploy from that particular release. The good thing about AWS is that it's smart enough to recognize if there are no changes in the configuration files, then it's not going to touch them. So that's why you can kind of safely deploy everything in one go. But yeah, by keeping like everything in separate GitHub repositories, it sounds like a best practice, but it's quite difficult to see in the real life.
Yeah, good tip.
Especially if you have that monolith, you know, that a lot of things like shared libraries, you know, as I said, testing, even like creating releases can become quite an interesting task. Then you need to create some metrics of releases from each kind of GitHub repository. So yeah, I was trying the first approach, but then switched to one repository.
Excellent, thank you.
So you showed that the costs of the operation are much lower than, let's say, with the traditional system. But do you think that it's more expensive to build the serverless system than if we do the same code in the traditional way? Like, do we require bigger teams and like more experienced developers?
I think it doesn't take more time to build. It requires developers to obtain some knowledge. And I think that's the biggest problem at the moment. Because if you'll try to search for a good like serverless expert or a software engineer with the serverless experience or QA engineer with the serverless experience, it's going to be quite hard to find. Like I've been interviewing many people at HubCorp, and I think to fill one position it took us like 9 months, because it's quite it is growing, and that's why I think that you can actually attract a lot of talented people, but it's quite difficult to find someone with the right experience. As soon as you know how it works, it doesn't take longer to build, because pretty much you're still building the same thing. Like, you know, when you're creating some sort of API, you need to write some methods, and they're going to be exactly the same. But more to understand how all these kind of things can be bundled together, wired together. So in terms of time, no. In terms of cost, probably no. But you will have some problems hiring right people. Hopefully it will change because it's getting bigger and bigger.
Okay. And one more question. If I have the monolithic application and I'm looking to move out into the serverless world, can I still use MySQL database or any other relational database? Is it still possible with Lambda?
Yeah, absolutely. And even like if you use something like RDS, it's pretty much serverless service too, because you don't really have a dedicated EC2 instance. You just use RDS, and RDS, that's a service from AWS that allows you to host relational databases, and not just relational databases. Or you can use like some even like relational databases services. Like DynamoDB is a NoSQL database, but there is also, I think it's called Aurora from AWS. That's a kind of relational database. You can use MySQL, absolutely. You can just put it onto RDS. And that, even by doing that, basically your database becomes a little bit serverless. The interesting question here, and I think everyone has it, how to actually split that monolith into microservices. How to actually start maybe using some serverless components in your monolith application. I think if you're trying to just convert your monolith application to serverless application, it's not going to work. Basically, it means that you need to rewrite everything from scratch. What you can do, you can try to start separating some components that you can actually start moving out of your application. Like if you have an application and it's got, let's say, a payment system or authentication system, then you can actually probably start just separating and extracting those components from the application. I did that exercise. It's a longer process because you need to make some changes to the existing application to support that, as well as taking out and creating some new microservices. But I think it's probably the only option that you can do at the moment, other than just rewriting everything from scratch, that I think all developers love. And it doesn't mean that it's going to be a successful project, but yeah.
Thank you. You mentioned that it's quite difficult actually to migrate from one serverless platform to another one. What would be the main challenge if you want to move, let's say, from AWS to Azure? Or performance?
So many challenges there. So the first one, that not all services are exactly the same. Like you will see that they're trying to copy each other. So if we're talking about AWS Lambdas, Azure has a service called Functions, and I think Google also has something like, I think it's called Cloud Functions or something. Or same like DynamoDB, it's kind of similar to Cosmos DB from Microsoft. The biggest problem is that you have those, basically you need to rewrite all the infrastructure as code. Like you need to rewrite all these deployment or configuration files. Because obviously when you create a Lambda or something like that, then in the configuration file you will have all things specific to AWS. I think it's one problem. It's just a bit time consuming. Another problem will be to test that all that stuff is working the same way as it's been working in the previous provider. So I think the testing will take a significant amount of time. And probably one more will be related to some services that you used in one cloud provider might not be even available in the other cloud provider. And I think some businesses were trying to do that exercise by moving from AWS to Azure. They just ended up using some services from AWS and some services from Azure. And that comes with another limitation, because obviously when you run everything under one cloud provider, you can utilize all the networks that that cloud provider has. And like Amazon has a dedicated lines to connect their regions and to connect their availability zones. So instead of just sending data over the internet, you're utilizing, like if you're trying to download something from S3 bucket to AWS Lambda, it doesn't send that request over the internet. It's just using the underlying infrastructure. So if you start using like both cloud providers, you're probably going to lose a bit of performance. And they know how they make money. And they make money by keeping people very kind of attached to them. And that's why it's like Apple, you know. You can get the full experience of kind of Apple services if you have MacBook, iPhone, and iPad. It's quite difficult to integrate, like, I don't know, Surface Pro and MacBook. And I think they're trying to do the same thing. They're trying to make your migration as hard as possible. That's for sure.
Thank you.
Thanks, guys. All right. Well, yeah, thank you very much, Illia. Very much appreciate your time here. And yeah.
Thanks for having me.
Thanks, everybody. Thanks, everybody, for coming. So we are having a break in September, and we'll be back in October. Again, a personal development type event rather than technical. It's about mental health, something that's very important at the moment. A very awesome presenter named James Patterson will be attending here on the 8th of October. So keep up to date with our mail-outs and Facebook and Eventbrite, and we look forward to seeing you then. Thank you. Good sound.